Today, vector sets, which is the new Redis data type that implements vector similarity, did a very big step forward. And I released internally, and I hope this release will hit the public repository of Redis as soon as possible. But I released filtering, which is basically the ability of vector sets to don't just retrieve items which are similar to a given query vector, but also that satisfy a given expression. So you can filter by a scalar and then get similar items. For example, normally I will do something like give me the similar entries to the element banana, and I get this returned. However, with this implementation, it is possible to associate to each of the elements inside a vector set a set of attributes. For example, let's get mango. We get attr word embeddings attributes mango, and this item has an associated JSON string, which in this case contains just a field, which is the length of the word itself. So I can exploit this fact of the ability to associate with, you can set attr, or when you add a new item to a vector set, you can also use the set attr option in order to set also the attribute other than the element in a single step. So with the filter option, I can specify, for example, what you could write basically inside an if expression of JavaScript. I just want items which will satisfy this expression. And I get sago, beans, pears, rice, cocoa, and so forth, coca, figs, and so forth. Before to explore other features, of course you can do complicated expressions like and .len equal 8, or .len equal 8, and you get, based on, of course, on the similarity score that you have, you get both elements, or you can also use, whatever you would use inside a programming language. Instead of 8 here, I can write 4 plus 4, or reference other fields of the JSON attributes and whatever I want. Before zooming inside what are the user-facing trade-offs when doing that, I want to show you the implementation. The main loop of the HNSW search algorithm is quite simple. However, I had to make it a bit more complicated because we have a filter callback here, and this is how it changed. This is the main loop that processes candidates, and as it finds better candidates or better results, will push them into the priority queues. First difference, I have a max effort parameter, which is different than the EF parameter of HNSW. This is the maximum number of nodes that we will visit, whatever we arrive or not to the maximum, to the number of requested items by the user. This is very important because certain times you can have a filter which will match a very small number of items in your HNSW. So you have millions of millions or even more items, and you select with the filter something that just 0.001% of items have, or even no item have. And we don't want to trigger a full scan when this happens. So by default there is a max candidates that you can tune from the API. Another very important thing, normally this break condition, which is a fundamental characteristic of HNSW search algorithm, is just this part. Okay? If basically this current distance is basically the candidate, the worst candidate that we have. If our candidates are starting to be not interesting in order to refine our results, we stop the loop early. However, in the default algorithm, this will never happen as long as we didn't accumulate EF elements in our result set. But after the modification, that's possible, because as you can see here, when the filter callback, the standard algorithm is this one. So when I find a better neighbor, I put it both in the candidates and in the results. And this means that if the results are still not full, I will have it will not ever happen that basically that this condition is true, because I'm pushing in both sides. However, when the filter is not null, as you can see, the push conditions for the candidates and the results are different. Then I have to make this condition explicit, and this is the reason why without the max candidates, this could trigger a full scan of the algorithm. But otherwise, the algorithm remains the same. And in order to model these expressions, I wrote an expression engine here, which supports, the usual operators, parenthesis, not, POW, multiplication, division, modulo, and the usual comparison operators, and so forth. I didn't want to add a programming language just to do this kind of things. Simple things must be simple, even if today nobody cares anymore, but I care. So what happens is, if I go and put a condition which is not met, perhaps, it still returns immediately, because there is the max effort. Normally the max effort will do as much work as 10 times the number of elements, or 100 times the number of elements that we asked for. Because the default count is 10, this means that by default we will visit as at most 1000 nodes. But we can control this with, for example, let's pick something which is a bit less extreme. Exactly. With length 30, the length of this dataset, that by the way it is possible to download from the internet. I put it in the README, so if you want to play when the sorted sets, the vector sets will be released, you can play with this. The length of the word of word2vec is very interesting, because the distribution is like logarithmic, and very long words are extremely underrepresented. So to test this is fantastic. But I can also add a filter effort in order to to do more work than that. And now I get finally the 10 items, even if they are so rare. And as you can see, the reply is no longer instantaneous. What's cool, however, is that even if I specify a very large effort, but I specify a filter which is very common, it will be immediate. So the problem with the effort is only just when the cardinality of our filter is basically extremely high, so it will be too sparse. From this point of view, there is something to say. When I don't use a filter effort and I get just 2 items, as you can see, they are very instant, okay, from my query. So the reality is that you really, when it returns very few results, probably it's okay because you don't really want very far results. And but still there are use cases and use cases. That's it. I believe that with this feature inside, we are going to be we are going to have the missing part in order to make vector sets massively useful for vector similarity tasks. And I really cannot wait to release it in order to see, actual users hacking with the implementation, finding bugs, limitations, or saying me, this is so cool, it works very well, which will be the best outcome. But I don't expect so much, so I am prepared to fix bugs initially. Okay, thank you for following. Bye.